afternoon, Food Safety ARC customers. I'm Mark Carter, President of Food Safety ARC. I want to thank you for joining our webinar today. I'd also like to thank our exclusive partners, Q Laboratories, Food Safety Tech, and Thermo Fisher for their help. And I'd also like to introduce you to one of our new partners, and this is Accelerated Technology Laboratories, Inc., or otherwise ATL. And ATL specializes in crafting technology into tools to automate your laboratory and other business operations for the purpose of making your daily work more efficient, more accurate, and overall easier. So I've got a little housekeeping that I want to take care of as we start the webinar. And it's just a few things that we need to do for you to understand as we go through. So during the webinar, each of you is muted, and if you have a question, there's two ways you can ask. First, you can raise your hand on the control panel, and we'll unmute you to ask your question. And then the second is you can type your question into the chat box, and we're able to ask the question directly to the speaker. So the main thing for you to understand is that we've got two ways for you to talk to us, and we hold the questions basically until the end of the webinar. So with that, and without further delay, I want to introduce Mohammed Ahmed, who will present Lean Laboratories Achieve More. Ahmed?
Thanks, Mark. Thank you very much. Again, welcome everyone. Hello, Food Safety ARC customers. My name is Mohammed Ahmed. I want to thank you for attending my webinar today. Let me tell you a little bit about myself. As a consultant lab optimization, in my current role at bioMerieux, my job is to understand and shape client requirements into holistic business transformation solutions. Immediate responsibility include developing lab optimization solution, portfolio targeting client market segments such as clinical, biopharma, wet, and agri-food. I lead and facilitate project teams of business and process experts to identify, recommend, prioritize, and resolve improvement ideas while managing process improvement initiatives utilizing internationally recognized methodologies such as Lean and Six Sigma. During assessment and lab projects, I conduct end-to-end process analysis and lead Kaizen sessions, providing leadership and critical thinking. Today, we will continue the lab optimization webinar series. Let me tell you a little bit about how this series came to be. Food Safety ARC recently surveyed food safety professionals to report on the challenges they face in their laboratories. When the results were tabulated, they concluded that time, money, and people were at the top of the list of severely limited resources. Additionally, the comments that were provided in follow-up interviews told a very similar story, that workloads and responsibilities are increasing faster than available resources will allow. The fact that you are attending this session today most likely means that you may have asked for additional headcount or budget. You might need additional training. Maybe you need to hire someone with a specific skill set or competency. Or maybe you just don't want to work 10, 12, 15 hours a day. One of Food Safety ARC's customers summed it very nicely when she said, "Mistakes will be made when these conditions exist, and that can prevent us from achieving our primary goal, to protect consumers." To address these conditions, Food Safety ARC developed the Laboratory Optimization Series. This series is designed to help you find hidden resources that you never knew you had. Today, I plan to spend the next 60 to 75 minutes taking your lab from good to great and talking about how you can transform your lab into a performance-driven lean lab. Let's get started. The agenda, I have it very simple. We'll talk about introduction to lab optimization. We'll talk about the methodology that I use on a daily day-to-day basis the Lean Six Sigma methodology. We'll also cover a Lean Lab assessment case study, and then we'll wrap up in the end with any question and answers. Let me ask you a couple questions. Are you making the most of your lab today? Do you need a roadmap to optimize your lab workflow and performance? Do you think it's possible to dramatically improve the efficiency of your work and the quality of your results with the resources you already have? To find out more and to answer these questions, let's move on to the next slide and start the presentation. First, I would like to start with a quote from Parkinson, also known or called as Parkinson's Law. Parkinson's Law basically states that work expands so as to fill the time available for its completion. Put in other words, the demand upon a resource tends to expand to match the supply of the resource. Let me give you an example here. Let's say that in your lab you have 2 staff who are working 8 hours per shift in a given day, and if you give them 100 samples, well, common sense is that they will split those 100 samples into 50 each, since there are 2 people doing the test, and then each staff will take 8 hours to complete the testing. Now let's increase the sample size to 500. What happens? The same 2 staff will now split 500 samples into 250 each, and each staff take 8 hours to complete testing 250 samples. As you see, the amount of work and the given time really plays a critical factor on a day-to-day basis. You also see that staff are always trying their best given the amount of correct resources. To justify this, let's look at what quality guru Deming mentioned. 85% of the reasons for failure to meet customer expectations are related to deficiencies in system and process. What basically this says is, in order for you to start improving lab operations, you need to start looking at your process first before even you look at your instrumentation and your staffing. The challenges today that I have seen, based on the experience that I have in this field. By the way, I travel to a new lab every other week. I mostly work from the field. I'm moving from one lab to the other lab, improving effectiveness and efficiency in laboratories. And talking to many of the managers and supervisors and lab directors, these are the challenges that labs face on a day-to-day basis. What you see here are few of the challenges that labs across the globe face on a day-to-day basis. I see the same problem and challenges over and over again, whether I'm improving a lab in US, in Latin America, in Canada, in Thailand, or any other country around the world. So my question to you now is, what is your approach to meet these challenges? On which lever you plan to act? Is turnaround time important to you? Is timely reporting of relevant information? Or is compliance and increasing regulatory compliance is a priority to you? Let's discuss this further and see how lab optimization provides the benefit of meeting these challenges on a day-to-day basis. Here are the benefits that I have listed. Some of them are increased efficiency, increased quality, increased productivity, increased labor utilization. Now, these benefits are achieved using a 5-step approach to lab optimization, which includes, let's say, the first one and the very important step is a complete lab performance assessment. And this should be a comprehensive deep dive analysis of all your high impact value streams. You can do this by volume, by customer, by pricing, etc. So basically, you need to study your process from start to finish, from the time the samples are received to the time the report is sent out. And that is what when I say value stream. So you need to pick your biggest volume value stream. It could be your biggest customer value stream. It could be your biggest pricing value stream. Once you have a thorough understanding of your value stream, then you move on to developing a lean roadmap, which will be tailored specifically for your lab, with a focus on workloads, resources, organization, productivity, and turnaround time. So these are the key performance indicators that you will need to start monitoring, measuring, and sustaining on a day-to-day basis. The third and critical step is to implement suggested recommendations and leveraging key performance indicators or metrics. So once you know whether you do your workshop session or you do a 5S session, and I'll talk about 5S after a little more slides. So whatever solution you reach to, you need to ensure that solution is effectively implemented and sustained over long term. As you see, there is no right approach. Having the right balance of people, process, and technology can help you adopt a holistic view of the entire organization to make right choices in your employment or deployments. Put simply, people, process, and technologies are all important aspects of lab operations. I'm sure all here will agree that we cannot build the lab of the future without the challenges you face in each of these three components as addressed. Let's talk about people. What are the key issues? Who owns the process? Who is involved? What are their roles? Are they committed to improving it or working together? You need to identify these critical factors. And then you need to look at your process. A process can be defined as starting with a trigger event that creates a chain of action that results in something being prepared for a customer. And in micro labs or in many of the labs, this is the sample receiving section. Once when you receive all the samples, that is your trigger point. And with the volatility that exists in many of the labs, we need to find out what the spikes are in your lab. You know, what are those times when you are being hit by these samples? In a production environment, this could be when is production sending in samples. In a reference lab, when are the couriers coming in? When are the other sample boxes arriving? When are the drivers key times or the highlight times in the day when these samples arrive? Focusing on high-frequency transactions can have significant benefit to standardizing the process. And what I mean by this is the key times when your samples are arriving. With technology, once you have your people aligned and the process developed and clarified, technology can be applied to ensure consistency in the application of process and to provide the thin guiding rails to keep the process on track. And this is where automation comes in place. It could be at the front end, it could be at the back end. Automation provides that consistency and removes subjectivity from your process. Lab operations is a very time-based strategy. Let's talk about lab operation, the nature and the behavior. You will see lab environments have a time-based strategy. To better understand this, you first need to understand lead time. Lead time is the time taken for one sample in your lab to move from sample receiving to reporting. This lead time consists of both value-added and non-value-added activities, and more to come on value-added and non-value-added activities in the next slides. So just bear with me here until I explain the concept. In a given normal lab, where focus is receiving, testing, and reporting, the ratio between value-added and non-value-added activities is somewhere around 20% of the work is value-added, 80% is non-value-added. And that is the norm. The traditional approach or the non-lean approach for improvement is to start small and big projects to significantly improve value-added activities. And many labs, at the management level, they never focus on significantly decreasing or eliminating non-value-added activities. Believe me, this is the wrong approach, which does not result in real improvements. And once solution is implemented, it will not last long. The Lean and Six Sigma methods is to eliminate or significantly decrease non-value-added activities from your lab testing process. And this graphic explains the Lean approach in the simplest form. So what exactly is Lean and Six Sigma and Lean Sigma? Some call it Lean Sigma too. These are basically business management strategies commonly used in production industries to improve process efficiency and qualities. Now what happened is during the past decade, these process improvement techniques increasingly have been applied outside the manufacturing sector. For example, in healthcare, in banks, in insurance companies, and lab environments. Lean, which is also known as lean production, lean enterprise, lean thinking, by the way, all are, they mean the same, involves a set of principles, practices, and methods for designing, improving, and managing processes. So they're very process-focused. The development of lean is actually attributed to Taiichi Ohno's articulation of Toyota Production System, the TPS. Ohno was a chief engineer at Toyota who aimed to improve efficiency by eliminating particular kinds of waste called muda in Japanese. That's basically waste. And I'm going to talk about what waste is. There's visible kind of waste and invisible kind of waste. The invisible kind of waste is what we need to keep in mind, need to identify and significantly eliminate from the process. Six Sigma, on the other hand, is like Lean, which is a business management strategy and is used to improve the quality and efficiency of operational processes. And the best way to remember this is when I'm talking about Lean, the primary metric I'm using is time, the turnaround time in labs from start to finish. And when I'm talking about Six Sigma, it's all about rework, it's about variation, it's about, improving tasks at the actual workstation level and reducing this process variation to improve the process. So moving on, let's talk about the different types of activities that happen in the lab. There are basically three types of activities, and only three types, believe me. The first one is value added, the second one is business value added, and the third one is non-value added. And the graph, the picture here clearly explains the amount of non-value added activities that happens in any normal lab environment. Value added activities increase the form or function of the sample. Typically, this happens only about 10 to 20% of the entire process. Whereas non-value-added activities does not add any form or function to the sample. Basically, these activities should be eliminated or significantly reduced from the process by simplification or integration. On the next slide, I'm going to give you some examples of what exactly value-added and non-value-added activities look like. Value-added, anything, sample reception, ordering supplies, sample preparation, incubation, reading, sending report to customers, those are all value-added. Again, to sum it up, this is something that our customers are willing to pay for. Our customers are not willing to pay for waiting, for moving samples, for any inspection, for checking, for copying. Those are non-value-added activities simply put together. Some other examples I can give are sample splitting. What about sample retrieval or, from the archiving to do the rework? Any manual archiving, manual logs, manual dilutions, extra calibration, that's a very good example. Calibration may be required just once or twice, but I've seen many times that a lot of the times calibration is done multiple times just to ensure that the instrument works good or an instrument meets the specifications. One of the biggest waste I have seen in labs is scientist level people, so, even PhDs and master's degree holders, they are washing dishes. Now that is underutilization of skill, and that is one of the biggest invisible waste that exists in the labs. These people should actually be doing some experimentation work. They should be reviewing the reports. But many times I have seen these people, doing housekeeping work. So those are the things that we need to keep in mind and ensure that non-value added things are significantly removed. Now, in addition to value added and non-value added, I also talked about business non-value added activities. Those are your compliance, meeting compliance activities. This could be such as internal audits or logging into to ensure traceability. Again, these business required non-value added activities cannot be removed, but at least we should try to significantly decrease these activities and ensure that they're not being done over the required specification. Once we understand value added and non-value added activities, let's move on to the type of waste. And this is the type of invisible waste that I was talking about in my prior slides. There are 8 types of non-value added activities or waste that happen in any laboratories. And Lean is an extremely powerful tool in identifying and eliminating these 8 wastes. During the assessments that I do, we look at the timeline from the moment the sample is received to the time the report out is sent out. And our goal in the assessment is to find out the right solutions to reduce this time by removing the non-value added waste. Let's talk about defects. Any work that contains errors, reworks, mistakes, or lacks something necessary. Overproduction, a good example, is making more media earlier or faster than is required. Waiting is another critical waste. Any idle time created when samples or information or people or equipment are not ready. Not utilizing employees' knowledge, skills, and abilities, we already talked about. I gave you an example. This is the waste of not leveraging technician and analyst full talents and capabilities. Then on the list is transportation. A good example would be movement of samples and materials that add no value. Let me give you an example. One particular lab that we did an assessment, what happens is the samples are received and logged in a separate building, which is about 100 to 200 feet away from the lab. So once the samples are received, logged in, they are put in a cooler, and then they are transported to the lab. And this is pure transportation waste, which is physically, visible at the same time from a Lean perspective. This one should be immediately, removed from the system, and the transportation resources that are required can be better used for other value-added activities. Inventory is another one. Let me give you an example. One particular lab, what happened is there were no technicians in this lab that required a medium-sized gloves. There were technicians who were using small-sized gloves, and there were technicians who were using large-sized gloves. But when the inventory was ordered, all 3 types of gloves are being ordered. And what happened is when I went into the inventory section, I noticed that there are 2 boxes of medium-sized gloves. There are 2 boxes of large-sized gloves, based on the safety stock calculation and their Excel spreadsheet that they maintain. But at the same time, they had 22 boxes of medium-sized gloves. I said, why? And when you start asking the question why, you come to know that, first of all, there is no employee or staff who has, who use the medium-sized gloves, but they just kept ordering and ordering, and the inventory started being piled up. Now, in this case, there's no expiry date, But what happens when you order reagents such as this, and there's an expiry date on the reagent? And pretty soon, your expiry date will come across, and that reagent will be of no use. The other ways we see a lot is motion. And motion, I mean at the workstation level. People just moving their hands, searching for things, looking for things, or the right thing. A particular example I can give is, when one of the technicians who was doing working on a standard operating procedure required the use of a automated machine, which was about 10 to 15 feet away from where he was actually doing all the sample preparation. And every time he needed to use this machine, for every sample, this person was moving to his right side, walking all the way to this machine, performing that activity or task, and then returning back to his place. And if this person tested 100 samples, he made 100 rounds just to go and use that machine. The best option was when we started asking why, the technician, it was suitable for him to just move that machine closer to his sample preparation area. He even had a power plug and everything available, and that way he saved making all those rounds. The last but not the least of the waste is excess processing. Now, the easiest way to remember these waste is just remember downtime. D stands for defects, O for overproduction, W for waiting, and then similarly. So basically, what exactly is lean laboratory? I have listed some of the tools that we use during our assessments to create the lab of the future. We basically start from asking what value is being brought into this lab by the external customers. And then we start focusing on improving that value or creating value. And remember always, value is defined by your external customer, not your internal customer, not your management, not your internal lab staff, but it is defined always and always defined by your external customer. Some other tools that you can immediately start using after my presentation is 5S, improving flow in the lab, standardization, and demand management. And we'll talk about this during my case study, as well as I have one more slide that I'll cover in depth about, we'll talk about 5S. So let's face reality. Starting the lean journey in any lab can be difficult. It is critical to have alignment and clearly state the need for improvement from the beginning. Now that we understand what a lean lab is and what tools to use, we'll talk about how to build this lean laboratories. The first and important step for you is to standardize your process. When we do our assessments, how many times we see there is variation of work from staff to staff. One person does it another way in first shift, and then if you see the same process happening in the second shift or third shift, it is completely the opposite. So you basically, and they're still following the same standard operating procedure, but some are doing it good, some are doing it bad. The ideal way is to find out who that best technician is, who has the best approach, who is following the SOP closely, and then request that person to train the second, third, or first shift persons just to get them up to speed. This is called cross-training your teams. And then you need to predict your daily demand. In the beginning of my presentation, I talked about identifying those spikes. From time to time, what are those critical times of the day when the samples are received? Once you know those critical times, you need to calculate your takt time. And I have given the formula below here. Takt time is basically the number of staff you have in your lab, that divided by daily lab operation hours, which could be 8 hours, 16 hours if you're doing, if you're running 2 shifts. Again, this total divided by the daily test demand will give you the takt time. For many labs, this comes up to 30 seconds to 40 seconds per sample if you're doing almost, 1,500 samples per 8-hour shift. But this number really varies from lab to lab. So it's nice to calculate takt time, to at least calculate it on a monthly basis and see where you stand. Are you having the right number of staff? Are you working the right number of hours? It kind of opens up, a door to really balance your laboratory operations on a day-to-day basis. And then once you identify your takt time, you need to adjust staff. Many times we have noticed that staff really start at 6 a.m., but they have nothing to do until 9 a.m. because 9 a.m. is when the couriers come in. So basically, they do housekeeping, they do all the calibration in an hour, and then we do see, I'm not saying that this happens in every lab, but some few of the labs that we visited, we saw there's almost 2 hours or at least like an hour of time in the morning where the staff have nothing to do, but they're starting very early. So you need to match the staff to match, adjust the staff to match the existing demand, accounting for breaks, lunch, etc. And then once you have this in place, you track your workload and progress, and always remember to react to variation, because variation is a disease that needs to be diagnosed and taken care of immediately. Now, we also follow a roadmap when we are building a lean laboratory. And what you need to do is first, you need to really identify that burning platform for change, because change is necessary to move from good to great. And if you don't have that burning platform for change, then you see many hurdles on your path to improvement. Once this burning platform is identified, you need to identify the waste that we talked about, the 8 types of waste. This, you can use your lean eyes now that you have been trained, you know how to identify this waste. Once you go back in your laboratories, start seeing the lab with your new lean eyes and see how much waiting is happening at the workstation level, how much extra processing is happening, extra motion is happening. Those are the things that you need to immediately start reducing in your labs. Once you identify the right amount of waste, then you develop your lab-specific plan for improvement. You come up with that roadmap and say that, okay, I'm going to 5S this lab in the next month, and then I'm going to remove existing transportation, which is 100% today. Maybe I'll take it down to 70% by moving some instruments or moving some workstations around my lab, or even moving the sample preparation to closer to the instrumentation. See how far your incubators are located, things like that. And then once you have this roadmap, you need to implement the change. Implementing change is, once you have properly motivated staff, this is done, in a Kaizen session. You can do it over 2-3 days, run it on a pilot phase and see if everything works, then you standardize the process. But also very, very important and critical is you need to measure, monitor, and sustain your results or your achievements. Now, 5S is a workplace organization, and 5S basically can be broken down into 5 steps. The first step is sort. What you basically do is, you pick a small area in your lab and you decide, okay, this is going to be in the next week, I'm going to 5S this area. So you start with sort. You need to sort through all items in a given area or bench station. The best way to do this is by placing a red tag or a sticker on all unneeded items and moving them to a temporary holding area. And I believe this one really works. Then you go to the next step, which is set, and you do this by identifying the best location for remaining items. Now you have sorted out the needed and unneeded items. So relocating out-of-place items, setting the inventory limits, and you can use Kanban, which is inventory management lean technique, and also installing temporary location indicators will help you setting things in order. The third step is the shine, which is not different from just cleaning everything. It doesn't mean that if you're doing housekeeping, you're following the shine step completely. You need to continue to inspect items by cleaning them and to prevent dirt, any contamination from occurring. Once you have sort, simplify, and shine in place, The last two steps in implementing proper 5S are very critical, and this is where a lot of big and small labs drop the ball. Standardizing means to creating rules for maintaining and controlling the first three 5S and using visual controls. Visual controls really help. And this can also be done by the simple use of, you can use SOPs or work instructions and ensuring proper updates are happening to these documents from time to time. I don't want SOPs to be written, or a process to be written on 5S, and then it doesn't become a living document. It just goes, you file it in some binder, and it stays as it is. So basically what I mean to say is 5S is often a great starting point for many laboratories, and over the years the instinct to hold on to things just in case has allowed many labs to build up endless clutter. Just go back in your lab and see how much of unused instruments or equipment your lab carries today. And if you just red tag those, you will be astonished. You'll be surprised on how much unneeded things you have collected over the years. 5S can also be seen as the foundation for all other activities. Let me say this, without 5S, it could be very difficult to achieve maximum results. So I highly recommend 5S is the place, and you don't need to 5S the whole lab. Start in smaller chunks, and then you move on. You pilot your phase to one area, you see how things are working, and then you apply the same method to a different portion of your lab. Now, so far I have been talking about, the lean basics, what exactly lean is, Six Sigma is, what a lean lab looks like, benefits of lab optimization. We covered all the basics, or the 101, the foundations for lean. Now let's put all this together and talk about a case study. And this case study, this is, as a long-term partner with bioMerieux, we help this lab look at their lab from a different angle. Our workflow optimization or lab optimization services, which combines management techniques, from Lean, Six Sigma, and 5S, along with a micro expert or a subject matter expert, really enable this lab not only to meet their challenges, but also exceed customer satisfaction. And as you see, this is a very, like a normal type lab. They are, lab is committed to providing analytical testing services. They are 17025 certified. They are based in US. The lab has a variety of clients. So this improvement methodology really applies to each and every lab. It doesn't matter whether you're a small lab, you're a big lab, you're a production lab, you're a service lab, you're a reference lab. Basically, this methodology covers everything. As far as the scope of the assessment was concerned, the objectives and focus was met using lean principles. The assessment was basically divided into three parts. In the first step, the workplace organization was studied, and I mean thoroughly. We value stream process mapped their process, and we observed standardization of work, how much standardization exists, and we also look for any visual controls, how strong they are on visual controls. Once we studied or observed their current process, second, we looked at the people or staffing side to ensure work effectiveness and quality of the source was achieved. And in the last, the workflow was observed as a system to create cellular flow, reduce sample batch size, and we created a pull versus a push system. And pull and push are lean, pillars. What basically it means is you should have a pull process. Samples should actually be pulled and not pushed into the lab. And once you create a continuous flow, a proper flow, you see, results coming in. We also used a lean assessment matrix to identify existing process improvement gaps. Other lean tools such as spaghetti chart, logic flow diagram, standardized work, and other charts were also used. These are the graphs that were obtained, for their current analysis. And current analysis is very critical when you are working towards your improvement. You need to know exactly what type of samples you're receiving, what's the percentage looks like, where's your focus area, what is the #1 value stream that you need to work on. It could be on, again, volume, or it could be, again, on your customer, your biggest customer, or based on pricing. But you need to stratify your volume or your samples in order to better understand, the improvement roadmap. In this case, we also did an instantaneous observation analysis. Basically, we used Visio and we came up with a lab, layout. This is their current lab. This is how the lab looks. And then once we have this, we identified areas in the lab where we want to randomly start gathering data. Now, you see these Googles or specks. Those are the points that were identified throughout their lab. And we started collecting random data, and the random data that we collected was based on these different types of activities, or the data was put into different buckets. The first one was technical. How much technical activity is happening on each of those locations identified? How much admin work is happening? Transportation, if any transportation is happening. What about movement? What about walking and other activities? Sometimes it could be any meetings that is happening at that point, any cleaning activity, someone's on a phone call, it could be any social chat. Those were all put together in the other category bucket, and we started documenting or collecting random data for these 6 categories. Once we had enough random data, from a statistical perspective, we used data analysis software, and we came up with this chart. In this particular lab, as you see, there's about 26% of admin activity happening, and that's a lot. That's basically a lot of time your staff are spending. Then followed by 22% of your staff time is being spent in walking, followed by technical activity. Now, ideally, what is expected is if when we look at value-added and non-value-added activities, the technical activity is what you should see more happening. On an average, in a given lab, I would say about 60% of the activity should be technical in any lab. And the reason I'm telling 60% is because walking, others, and transportation and movement, the lean waste, the red bars that you see, cannot be fully eliminated from the system. No matter what, there will be some transportation happening. No matter what, there will be some movement happening, some walking happening. The trick is to significantly decrease this lane waste and improve your green bar, which is the technical bar. And the way you come up with this type of bar is by collecting this random data on all those 6 activities. So there's a structured process, there's a structured lean tool that you use, and then you come up with this. Once you identify on a percentage basis where exactly you stand, if it's in this situation, a suggestion or recommendation would be to move from manual to electronic system, or start logging in or removing duplication of logging in, or at least bring in a LIMS, laboratory information management system, and that will automatically decrease your 26% of admin work down to at least, say, 10 to 5%. We also did analysis on the capacity versus workload assessment. The key or the highlight of this slide is basically you should see where gaps exist in your process and where you have free capacity available in the lab when it comes to your lab people. Once that is identified, then you will go ahead and you'll start coming up with solutions and implementing those solutions in order to keep your staff busy. As you see those, the gray balls around, those are the times when there was capacity to perform other tasks. And then once those gaps were identified, tasks or activities were given to individual staff to become more productive. And this type of analysis really increases your productivity metric. A spaghetti chart also really helps in bringing out the amount of extra motion and extra transportation that happens in your lab. This is a very, very visual diagram, as you see in here. With using different colors, we kind of documented the amount of walking or transportation that happens in this lab, and that is huge. Just the people were just everywhere. The incubators, as you see, were at the very end of the lab, where sample preparation was happening at the front end. So there was a lot of walking and motion and movement happening, and no one really, until we showed them on this presentation slide, no one exactly even knew. I mean, the staff were walking because they said, hey, this is how I was taught. And this is where I need to go. Once I have my sample prepared, I need to go to that incubator to incubate my samples. They never thought that they're taking 20 steps or 50 steps to move each of that batch to that incubation. So this kind of visually gives you an idea how much of waste exists. And once the current situation is identified, then you move on. And this is the future solution that we proposed. The incubators were moved. The sample prep area was rearranged or redesigned, and we came up with a better solution for them. And this minimized or significantly removed the extra lean waste that existed in this lab. So just by moving around some of the few things in your lab, your key performance indicators like productivity, turnaround time, and even staff used as a resource will significantly improve. And this is the proposed future state for the Listeria. So we came up with two, the Salmonella and the Listeria. So basically, in conclusion, the improvement elements were divided into 4 buckets. We had staff allocation. We worked on improving their process flow. The lab layout was changed, and also a laboratory information system was put into place. And the impact was huge. It improved turnaround time. Non-value-added tasks were significantly eliminated, improved quality, as well as less movement. They went from bigger batches to smaller batches. That kind of created that continuous flow in the lab, and this resulted in reduction of non-value-added tasks. On a percentage base, once we quantified the number, we did a follow-up assessment. We went back and we did, we recollected all the data, and lab efficiency increased by 22%, 80% reduction in motion and transportation, and that is the norm. So reduced motion and transportation, this is an average, what I'm putting out there. Every time we do an assessment, we provide a roadmap, short-term and long-term, and our customers implement the suggested solutions. They see this kind of improvement. Redesigning work area is very, very critical, and we do that all the time, because a lot of the time we go out there, labs are either like at least 20 years, 10 years old, and it's just a legacy issue. No one wants to move the equipment, instrument. You really need to have a fresh pair of eyes, a third person come in your lab with lean eyes and look at your process from start to finish. Basically, it also improved employee satisfaction. Now, with bioMerieux, the best thing is that there are tools available in Lean. There are tools available in Six Sigma. Working with bioMerieux as a consultant for performance solution, what I did is I cherry-picked or hand-picked the best tools available in both these internationally recognized methodologies, and came up with basically a plan for improving labs. There are many hundred some tools available out there, but some apply directly, some don't. So we hand tested the tools that really apply to lab environment, and we started using those, which gave us maximized productivity, and we also freeing capacity, reducing time to results, increasing quality of results. So basically, the benefit of using bioMerieux performance solution is all our results, all our roadmaps are tailored to meet specific requirements of individual labs. Every lab is different. Every lab is unique. Your lab layout is completely different to the other lab that I visit next week. So dramatically raising satisfaction level among your staff and customers, I highly recommend you going for a lean lab initial assessment and moving your lab from good to great. This is one of my last slides that I want to share with you is, the lessons that I learned over time is improvement is not easy. We as micro, or lab directors or lab, supervisors or lab managers, we need to understand that whatever improvement plan we come up with, you see the picture on my right-hand side, the guy on the bicycle, that's how your, milestone will look at if you see it on paper. Once you go ahead and start implementing your solutions, that is the reality is that's how it will look. You will have resources issue, budget issue, staffing issue. You need to start monitoring the metrics. I mean, how many labs out there today are monitoring simple metrics like turnaround time, productivity, staffing? Those are the basic key process indicators you need to start measuring, monitoring, and sustaining. Because if you're not measuring, you cannot succeed. And at the same time, you need to fail many times to win. And athletes know this more than anyone else because they try hard every day to win and they fail a lot of time, and you learn by your failures. So with that, I come to end of my presentation and I open up these dice for any questions.
Thanks, Mohammed. It was a great presentation. I just wanted to tell you how much we appreciate you giving this presentation. It's very helpful information. So one thing I would like to ask you, the floor is open to anyone who wants to ask questions, but just out of curiosity, how many labs do you see implementing Six Sigma techniques, and do you see that as a way for more labs, of course, to increase productivity? So the third part of the question is, are there some labs where these techniques don't work?
Yes, very good question, and my answer is Lean and Six Sigma methodology doesn't apply to each and every lab. First of all, like I said in my presentation, you need to have that desire, the burning platform. You need to be ready to make that change. You need to be properly motivated. At this point of time, you should have identified what are your biggest issues. Why do you want to improve? That would be the number one question. And if you know why, that's the time when this methodology will work. If you're not properly motivated, if you really want to do this as a fad of, maybe I'll do lean, I'll see how it works, or I want to, make some minor changes. I want to apply 5S in one section and see how it works. No, it's not going to work. This is a continuous improvement cycle. If you adapt Lean and Six Sigma methodology, this is going to be a cycle on its own. You will reach a certain phase, and then at that phase, you will have to start looking at what more can I improve, and then you go from there. So it's a step-by-step process. It's not a breakthrough process. You're not going to see results in 1 day or 2 days. To answer your second question, Mark, I would say there are two types of labs. There are corporate labs, big labs, and then there are small labs. The corporate labs, they have their own internal teams or, continuous improvement teams, but the bottleneck with these teams is they are involved, it could be a green belt guy, it could be someone, with a continuous improvement background working in this lab, but they are more involved in bigger projects, in strategical projects, and the lab is not a priority. So this is where, persons like me, we come in, we have a rapid solution for you. We are in on a Monday, and by Thursday you have a roadmap, both short-term and long-term, to at least start implementing the suggestions and solutions. So I hope I answered your question.
You did, thank you. To the audience, are there any other questions? Questions going once, twice? Okay, well, Mohammed, again, I want to thank you for your presentation. I want to thank our attendees for coming to this Food Safety Arc webinar, and hopefully you'll participate in some more of the lab optimization series that we're putting on. With that, I'd like to again thank Mohammed and thank the attendees, and we'll close the webinar. Thank you very much, Mohammed.
Thanks everyone for attending. Bye, Mark.
Goodbye.